In this particular question, we have to expand the given expression to first three terms and then determine the value of x for which is going to be valid. So let us begin by simplifying the given expression. So we have 2 plus x in the numerator. Now what we're going to do, we're going to consider the expression 3 minus 2x whole squared present in the denominator and move it to the numerator. And that should give us 3 minus 2x raised to the power negative 2. Then we are going to factor out 3. So that gives us 3 times 1 minus 2 over 3 times x whole raised to the power negative 2. And that should give us 2 plus x times 3 raised to the power negative 2 times 1 minus 2 over 3 times x raised to the power negative 2. On further simplification, we get 2 plus x divided by 3 squared, which is going to be 9, times 1 minus 2 over 3 times x raised to the power negative 2. Now we are going to expand the second expression, which is 1 minus 2 over 3 times x raised to the power negative 2 using the binomial theorem. So we will have 2 plus x over 9 times 1, the first term, plus n, so n here is negative 2, times x, so x would be negative 2 over 3 times x, plus the third term, which is going to be n times n minus 1 over 2 factorial times negative 2 over 3x whole square, plus the remaining terms. Since we were asked to find out the first two terms, so this is all we need. Now let us do the simplification. So this should give us equals to 2 plus x over 9 times 1. So we have negative 2 times negative 2 third. So the negative and negative will get multiplied together, become positive. So we will have plus 4 over 3 whole multiplied to x. Then we have negative 2 times negative 2 minus 1, which is going to be negative 3. So we have 2 times 3 is 6. So we have 6 over 2 factorial, which is 2. Then we have negative 2 squared, which will give us 4 times x squared divided by 9 plus the remaining terms. And this will become 2 plus x divided by 9 times 1 plus 4 over 3 times x. So 2 and 6 divided by 2 will give us 3. Then we have 3 times 3 is 9. So finally we'll have 4 over 3 x squared plus the remaining terms. Now we're going to multiply the first expression, which is 2 plus x, to the 3 terms. So we'll get, let me write 1 over 9 as the common factor. So we'll have 2 times 1, which will be 2, plus 2 times 4/3 of x, so that will be 8 over 3 times x, plus 2 times 4/3 of x squared will give us 8 over 3 times x squared, plus x times 1 is going to be x, plus 4/3 of x times x will be 4/3 x squared. And the final one will be 4/3 times x squared times x, which will give us x cubed. Now we're going to combine all the like terms together, and that should give us 1 over 9 times 2 plus 8 over 3 plus 1. So this 8 over 3x, 8 over 3 times x plus x are the common terms, are the like terms. So we're going to add them together. plus we're going to add 8 over 3 to 4 over 3 times x squared, and then we're going to reject 4/3 of x cubed because that will give us the fourth term, which we do not need. We need only 3 terms. So this would be 1 over 9 times 2 plus 8/3 plus 1 will give us 11 over 3 times x plus, and 8 plus 4 is 12, 12 over 3, so 12 over 3 is 4. So 4x squared plus the remaining terms, and then we finally multiply by 1 over 9, so that would give us 2 over 9 plus 11 over 9 times 3 is 27 x plus 4 over 9 x squared plus the remaining term. So these are the first 3 terms. So the first term will be 2 over 9, the second term will be 11 over 27x, and the third term will be 4 over 9 x squared. Now we will also have to find out the value of x for which this expansion will be valid. Valid in the sense that the expansion when we add the terms, it should converge. So for that we will go to expression. We'll use the expression 1 minus 2/3 of x raised to the power -2. This particular expression, because that was the one which was used to expand. So we have 1 minus 2/3 of x, 2/3 whole times x raised to the power -2. Now, to find out the value of x, we should have the absolute value of 2/3 of x must be less than the absolute value of -2/3 of x must be less than 1. So this would give us 2/3 times the absolute value of x less than 1. Now multiplying both sides by 3/2, so that should give us the absolute value of x is less than 3/2, or we can say that the value of x lies between -3/2 and 3/2, or simply saying that x belongs to the set of numbers starting from -3/2 all the way up to 3/2. So this is the value of x. Let's move on to the next question. In this particular question, we're given the expression 1 over square root of 4 minus 5x squared, and we have to expand it to the first 4 terms and also determine the value of x for which the given expression, the expansion of the given expression will be valid. So let us begin by simplifying the given expression. So we could rewrite it as 4 minus 5x squared whole raised to the power -12. Then we're going to take 4 as the common factor. That would leave us with 4 times 1 minus 5 over 4 x squared whole raised to the power -12. Now we're going to expand it. Let's take out the 4, so that will leave us with 2. No, it's going to leave us with 4 raised to the power -12 times 1 minus 5 over 4 x squared raised to the power -12, and this should be equals to 1 over 4 raised to the power of half times 1 minus 5 over 4 x squared raised to the power -12. Now 1 divided by 4 raised to the power half is simply square root of 4, so that is 1 over the square root of 4 is going to be 2. So we have half multiplied to 1 minus 5 over 4 x squared whole raised to the power -12. Now we're going to use the binomial theorem to expand it. So we have half times 1 plus n, which is -12, times x. So our x is -5 over 4 x squared. So that's it. Plus the third term, which will be -12 times negative half minus of 1 divided by 2 factorial times negative 5 over 4 x squared whole squared. And the last term is in the fourth term, which will be simply negative half times negative half minus 1 times negative half minus 2 divided by 3 factorial whole multiplied by negative 5 over 4 x squared raised to the power 3 plus the remaining terms. Since we are asked to find out 4 terms, so this much will suffice. Now we will simplify each of the values. So that should give us, this will be equals to, so let me write it down, half times 1 minus 5 over 4 x squared whole raised to the power negative half will be equals to half times 1. So we have a negative number multiplied to a negative number, so that will make it positive. So we have positive 5 over 4 times 2 is 8 whole times x squared. Then we move on to the next one. So we have negative half multiplied to negative half minus 1, which is negative 3 over 2. So that would be a positive half times 3 over 2. So I've removed the negative sign by multiplying the negative 1 to each other, divided by 2 factorial, which is simply 2 times negative 5 squared. That would be 25, and x squared whole squared would be x raised to the power 4 divided by 4 squared, which is 16. Then we move on to the fourth term. So we have negative half. So we have negative half times negative 3 over 2. So that would be negative half times 3 over 2 times we have a negative 5 over 2 divided by 3 factorial, which is simply 6, times negative 5 cube would give us a negative 125 times x squared whole cubed, so that will be 2 times 3, which is 6, giving us x to the power of 6 divided by 4 cube. So we have 4 times 4, which is 16, and 16 times 4 is 64, plus the remaining terms. This would be equal to half times 1 plus 5 over 8 x squared plus 3 times 4 and 4 times 2, so we have 3 times 8 and 3 times 8, 3 times this would be 75 divided by 8 times 16, 8 times 16 so 8 6 48 128. You can use a calculator and verify that this value comes out to be 75 over 128 plus, this will be plus because we have two negatives here and both of them will get multiplied to give us a positive number. So let me go ahead and use a calculator, and this should give me 625 divided by 1024 whole times x raised to the power of 6 plus the remaining terms. Now we're going to multiply half to each of the terms, and that should give us half plus 5 over 16 x squared plus 75 over 256 times x raised to the power 4 plus 625 divided by 2048 times x raised to the power of 6 plus ... So we have the first four terms, and that was what was asked. Now we will have to find out the value of x for which the given expression or the given expansion will be valid. So we use half 1 minus 5 over 4x squared raised to the power negative half, and from here we have to make sure that the negative absolute value of negative 5 over 4 times x squared is less than positive 1. Then we solve this inequality and that would give us the value of x. So we'll have 5 over 4, and the absolute value of x squared is simply x squared, because it's always a positive number, which is going to be less than 1. Now we're going to multiply both sides by 4 by 5. So we have x squared is less than 4 over 5. X squared is less than 2 over square root of 5 whole square. So what we have done, we have written 4 over 5 as 2 over square root of 5 whole square. Then we have x squared minus 2 over square root of 5 whole square is going to be less than 0. And that should give us x minus 2 over square root of 5 times x plus 2 root of square root of 5. And this value is going to be less than 0, and when we solve for x, we should get x belonging to negative 2 over square root of 5, comma, positive 2 over square root of 5. So this is an open interval, so that means the extreme values negative 2 over root 5 and positive 2 over root 5 are neglected. So these are the values. So for all values of x lying between these two extremums is going to make the given expansion valid. The expansion of the binomial expression, which we just found out, is going to be valid for all these values of x. Let's move on to the next question. So we are given the expression 1 over square root of 5 plus 4x. We need to expand it up to first 4 terms and then determine the value of x for which the given expansion will be valid. Let us begin by simplifying the given binomial expression. Not exactly a binomial expression, it's simply an expression. So what we can do, instead of writing the square root, what we can do is we can write it as 5 plus 4x whole raised to the power of half. And then we take it to the numerator, and that would give us 5 plus 4x raised to the power negative half. Then we factor out 5, leaving us with 5 raised to the power of negative half, all multiplied to 1 plus 4 over 5 times x raised to the power of negative half. So 5 raised to the power negative half could be written as 1 over 5 raised to the power of half, whole multiplied to 1 plus 4 over 5 times x raised to the power of negative 1 by 2. Now that we have in the simplified form, let us use the binomial theorem and expand it. We have 1 over square root of 5, since 5 raised to the power half is also square root of 5, times the first term, which is 1 plus n, that would be negative half, times x. So our x is 4 over 5 times x. This is the second term. The third term would be negative half, which will be n times n minus 1. So we have n times n minus 1 over n 2 factorial, whole multiplied to 4x over 5 raised to the power of 2, plus the fourth term. So we'll have n, which is negative half, times n minus of 1 times n minus of 2 divided by 3 factorial times 4x over 5 whole raised to the power 3 plus the remaining terms. So this will be equals to 1 over square root of 5 times 1. So we have a negative number here, negative number multiplied to a positive number, so that would give us a negative 1. So we have 1 times 4, which is 4 divided by 10, and 4 over 10 can be written as 2 over 5. And we have negative half times negative 3 by 2 divided by 2, which is the value of 2 factorial, times 4x squared, that would be 16x squared, divided by 5 squared, which is 25, plus negative half times negative 3 over 2 times negative 5 over 2, whole divided by 3 factorial, which is simply 6, times 4x cubed. So 4 times 4 is 16, 16 times 4 is 64. So we have 64x cubed in the numerator, divided by 5 cubed, which will be 125, plus the remaining terms. Now we further simplify it, and that should give us 1 over square root of 5 whole multiplied to 1 minus of 2 over 5 times x. So we have 3 over 4 in the numerator times 2 times 16x squared over 25. Then we have 3 negative numbers multiplied to each other, so that would give us a negative. We have 3 times 5, which is 15, and we have 2 times 2 times 2, which will be 8. So we'll have 8 times 6 in the denominator, times 64x cubed divided by 125, plus the remaining terms. This is divided will be equals to 1 over square root of 5 times 1 minus 2 over 5 times x. So we have 4 here, so 4 times 4 is 16, so we have 4 in the numerator, also 2 times 2, so that leaves us a 2 in the numerator. So we'll have 3 times 2, which is 6. We'll have 6 over 25 times x squared minus, so we have 8, so 8 times 8 is 64. Then we have 15 here, so which could 15 and 6 are both divisible by 3, so we have 3 times 2 is 6, and 3 times 5 is 15. Also 5 and 125 are divisible both by 5, so we have 1, and in the denominator we have 25. The 2 and 8 will cancel out to leave us with 4 in the numerator. So the final answer will be 4 over 25 x cubed plus the remaining terms. So now that we have the expansion, so this is the expansion of 1 over square root of 5 plus 4x. Now we have to find out the value of x for which the given expansion will be valid. So what we do, we consider 1 plus 4 over 5 of x. This is the binomial expression. So here our condition requires us that the absolute value of 4 over 5 times x must be less than 1. So that would give us 4 over 5 times the absolute value of x is less than 1. Then we solve by multiplying both sides by 5 by 4. So we have the absolute value of x is less than 5 over 4. So that would mean that the value of x belongs to the set containing the number negative 5 over 4 up to 5 over 4. So this is the value of x. So any values that lies between these two extremes is going to satisfy the binomial expansion. Let us move on to the next question. So we're given the expression square root of 9 minus 4x squared. We have to expand it up to first 4 terms and also determine the value of x for which the given expansion will be valid. So let us begin by simplifying the given expression. So square root of 9 minus 4x squared can be rewritten as 9 minus 4x squared raised to the power half. Then we factor out 9, so that will leave us with 9 raised to the power of half times 1 minus 4 over 9 x squared raised to the power half. Now 9 raised to the power half is simply square root of 9, which will be equals to 3. So we have 3 times 1 minus 4 over 9 x squared whole raised to the power half. Now we're going to apply the binomial theorem, so that would give us 3 times 1 plus n times x, which is negative 4 over 9 x squared plus n times n minus 1 divided by 2 factorial. So I'm simply writing it as 1 over 2 factorial times negative 4 over 9 x squared whole raised to the power 2 plus 1 over 2 times half minus 1 times half minus 2 times we have negative 4 over 9 x squared whole raised to the power 3 divided by 3 factorial plus the remaining terms. So we simplify it, and that should give us 3 times 1. So 4 and 2 are both multiples of 2, so we have 2 times 1 is 2 and 2 times 2 is 4. That will leave us with negative 2 over 9 x squared. Now we have half times half minus 1, which is negative half. So half times negative half will give us negative 1 over 4 times 2 factorial. So 2 factorial is simply 2 times negative 4 squared. So that would be positive 16, and x squared whole squared would be x raised to the power 4 divided by 9 squared, which is 81. Plus, so we have half multiplied to negative half multiplied to negative 3 over 2 divided by 3 factorial, which can be written as 1 over 3 factorial, and 3 factorial is 6, times negative 4 cubed will be 4 times 4 is 16, and 16 times 4 is 64. So we have 64 x raised to the power 2 times 3 is 6 divided by 9 cubed. So 9 times 9 is 81, and 81 times 9 is 729 plus the remaining terms. So we do the further simplification. We have 3 times 1 minus 2 over 9 x squared minus, so we have 4 times 2, which is 8, and 8 times 2 is 16. So that would leave us as 2 over 81 x raised to the power 4. 2 times 2 is 8, so 8 times 8 is 64. So we multiply all the 2's in the denominator, that would give us 8, and divide it to 64, that would give us 8 in the numerator. Then we have 3 times 2, and we have 2 times 4, so this gives us finally negative 4 over 729 times x raised to the power of 6. Now we multiply 3 to each of the terms, and that would give us 3 times 1 is 3 times 6 over 9 x squared minus 6 over 81 x raised to the power 4 minus 12 over 729 x raised to the power of 6. We define the remaining terms. So we can divide both 6 and 9 by 3. So we have 3 times 2, 2, 3. We can divide 6 and 81 by 3. So we have 3 times 2 is 6. And 3 times 27 is 81. 3 times 4 is 12. And we have 3, 6, 4, 3, 243. So the final one will be 3 minus 2 over 3 x squared minus 2 over 27 x raised to the power 4 minus 4 divided by 243 x raised to the power 6 minus the remaining terms. So these are the four terms. Now we have to determine the value of x for which the given expression will be valid. So we will consider this expression 1 minus 4 over 9 x squared. So we'll take 1 minus 4 over 9 x squared, and here we consider the absolute value of negative 4 over 9 x squared to be less than 1. So this will give us simply 4 over 9 x squared less than 1, multiplying both sides by 9 over 4. So we have x squared less than 9 over 4, and then we have x squared is less than 3 over 4. So 3 over 9 over 4 could be written as 3 over 2 whole squared. So we have x squared minus 3 over 2 whole squared is less than 0. Or we can simply write it as x minus 3 over 2 times x plus 3 over 2 is less than 0. So that means that x lies between negative 3 over 2 to positive 3 over 2. So any values between these two extremums is going to make the expansion valid.